Welcome to 4.2, slope of a line. Again, this is kind of a two-parter, but we're going to try to do this all in one video. We'll see what the timing is. Today's learning intention, I am learning to find slope and describe the slope of a line using tables, graphs, and real-world situations. Hopefully by the end of this lesson, you can say that I can identify the slope as the rate of change between 2 points. Again, slope, rate of change, unit rate, all kind of go together. I can calculate slope from a table or graph, and I can explain what slope means in a real-world context. That is where we want to get at the very end. But for right now, if we can look at a graph, look at a table, look at an equation, whatever it needs to be, and we can figure out what the slope is, we're doing what we need to do. So first things first, what is slope? We talked a little bit about it last chapter, but I'm going to bring in two words that you're going to hear me say over and over and over and over and over again. Slope is vertical change between any 2 points. Well, vertical, that's going to be the rise. Horizontal change between 2 points is the run. On occasion, you're going to see it as triangle y. Well, this triangle means change. So, change in y. Horizontal is triangle x, otherwise known as delta, but you don't really need to know that. Change in x. Depending on how far you take your math career, you will need to know delta, but for right now, just know that slope is rise over run. Rise is the change in y. Run is the change in x. We're going to talk about two different types of slope right now, positive and negative. Positive slope always goes up and right. Negative slope goes down and right. So again, notice how we're going up, negatives going down. Just a quick little note off to the side that you're going to want to write. We always look at points on a graph from left to right. From left to right, that's going up and right. From left to right, we're going down and right. Okay, that's as simple as that, y'all. So, finding the slope from a line, we're going to find these two slopes. First things first, if we look at this graph, is this going to be positive or negative? This is going to be positive. So our answer better be positive. How about example 2? Is that going to be positive or negative? Is that going up or down to the right? It's going down, so that should be negative. Okay. We are going to have 2 steps. Step 1. Label your XY coordinates. Step 2. Count, rise, and run. When you're given a graph, you don't have to do a whole lot. You can just count it out. So, they gave us 2 points. Right here and right here. We're going to label these. This is point 1. This is point 2. We need our x, y coordinates. So x, horizontal, left and right. X, left and right. Where does this point lie on this axis? We're not looking up and down right now. We're looking side to side. Where does this point lie on this axis? Well, that's at 0. Where does this point lie on the y-axis, on the up and down? 2. How about point 2? Where does this point lie on this axis? If we were to draw a straight line straight down, where would it meet? It would be at 3. And then how about along the y-axis? If we drew a straight line to the y-axis, that'd be at 4. So we've labeled our xy coordinates. Next step is to count our rise over run, our vertical change over the horizontal change. So rise over run. How much did it go up over how much did it go right? Well, if we count it out, 1, 2. That's our rise. And even draw a little line up to it. Then we're going to draw a line over. Hey, we create a little triangle. That might come in handy one day. Up and right. So 1, 2, 3. That's all we're doing for the start of this is just counting. Okay. How about example 2? And they gave us these 2 points. We're going to count the rise over run after we label the points. So point 1, where does it fall? They didn't give us numbers on this one, so we have to figure it out. But here's our x-axis. Isn't this point at the origin? So it starts at 0. How many up is it? 1, 2, 3, 4, 5. 0, 5. How about point 2? Where's this at? Well, that's 1 over and 1 up. So 1 and 1. How about our rise and run? This time we're going down. So would that be positive or negative? That number. Well, if we go down, we're looking at negative. So 1, 2, 3, 4. So our rise is negative 4 over, how many do we go to the right? 1. There we go. There's our slope. All we have to do when you're given a graph and you can figure out the points is count it out. How about from a table? The points given in a table lie on a line, find the slope, check your solution. Okay. So, this one, there's a specific formula we have to use. And this formula says change in y over change in x. What does this mean? We're going to take two y's. We're going to call it y2 minus y1. And we're going to divide it by x2 minus x1. Anytime you are given 2 points or a table or something like that, you're going to use this formula. You need to remember this is going to come up so many times over the next few years of your math career. Okay? You're going to use this formula to find slope given 2 points or a table. So you're going to use this formula to find slope when you're given 2 points or a table. Right now we're given a table. So what we need to do is figure out what x's and y's are we going to use. Well, let's label our table. Here's all our x's. Here's all our y's. The first x is going to be x1. The second x is going to be x2. You can stop right there if you want, but I'm going to come back to it because I'm going to show you a different way of doing this that might make the numbers a little bit nicer. The third x is x3. The fourth one is x4. The y's are going to follow that same pattern. y1, y2, y3, y4. We're going to use this formula exactly like it says and plug it in right here. We're going to fill in the boxes. y2 is right here. That's our -1. Minus y1. Well, that's -2. x2, we said was -2, minus x1, we said was -6. So now we got to do the math. Subtracting a negative is the same as adding. So we have -1 plus 2 over subtracting a negative, same as adding again. So -2 plus 6. So plug it in. -1 plus 2 is 1. -2 plus 6 is 4. You have your answer. Now let's say you don't like using negatives. If you don't like using negatives, just use different points. We may have labeled these x1, x2, x3, x4, y1, y2, y3, y4, but as long as you keep them the same, it doesn't matter. You can say y4 minus y3 over x4 minus x3. You could say y4 minus y1 over x4 minus x1. As long as you're using the same points. If you're going to use this -6, you got to use this -2. If you're going to use this +6, you got to use this 1. If you're using the 2, you got to use the 0. However you want it to be. I don't really like using negatives because a lot of times people get these mixed up in this step right here. So I want to use all of them that are positive. So if I was to fill in this, y4 was 1 minus y3 is 0. x4 was 6 minus x3 was 2. What's 1 minus 0? 1. What's 6 minus 2? 4. Well, would you look at that? We got the same answer. It's like it was meant to be. As long as you're using the same corresponding numbers, you're good. How about example 4 down here? I gave you a table, asked you to find the slope. Let's label our table first. x1, y1, x2, y2, x3, y3, x4, y4. You can use whichever ones you want. It does not matter. We can't really do the same thing we did up here where we got rid of all the negatives, but I want to make sure that I use x1. You can use any other set of points, but you definitely want to use x1, y1 because those are positives. So I'm just going to go with the normal formula. y2 minus y1 over x2 minus x1. Fill in the boxes. y2 was negative 1. y1 was 3. So negative 1 minus 3. Then we have x2, negative 7 minus x1 is 1. So what's negative 1 minus 3? Negative 4 over negative 7 minus 1. We get negative 8. What's a negative divided by a negative? Well, that's positive. So this is 4 over 8. Can we simplify that? Is there a number that goes into both 4 and 8 that you can divide by nicely? Yeah. Some of you are going to say 2, which is true. But is there a bigger number that goes into both 4 and 8? Yep. 4. What's 4 divided by 4? 1. What's 8 divided by 4? 2. Can you simplify that any farther? Nope. That's done. This was a quick look at finding slope from a table. I think you guys did a little bit of this last year, so hopefully this was a little bit of a review, but it all comes back to this formula up here. Can you use this formula to find slope given 2 points or a table? Right now we've only done it from a table. We could have done it on the other page here instead of just counting it out, but if you can count it out, I'd just count it. All right. So this was 4.2. We're just going to call this part 1 because we're getting close to 20 minutes here. So we'll stop it here and then we'll go on to part 2 next. Good luck.